Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Unveil by James Sinclair. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. The sum of the digits inside a cage is equal to the small number in the top left corner. So all of these cages add up to 20. So the 4 digits in the cage must add up to 20. So you could have something like, say, 3, 7, 9, and 1, and that would add up to 20. And that would be a valid example of these killer cages. We also have each purple line contains a pair of consecutive digits. So these are Renban lines. So for example, if this were say a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive. And that's an example of how Renban line works. We have digits separated by a V sum to 5, and digits in cells separated by an X sum to 10. And all possible V's and X's are given. That is, there are no V's. So we have the negative constraint here. If, for example, this were, say, a 3, this would have to be a 7, and we could not have a 7 or a 2 in any of the cells that share an edge with this 3 because there are no X's or V's marked there. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we're going to mark these as blue because they have to be the same set of digits adding up to 10. We're going to mark these as pink. We'll mark these as green. And these have to be red. So we know this has to be a 5 here. We don't know which one's low and which one's high here. These are all the different sets that add up to 10. So X cannot, so red cannot be here. Blue cannot be here. That's interesting. So what does that mean? Red and blue can't be here. That means at least one pair has to be in red, has to be in this cage, because green is different from red, and pink is different. So these are all different, right? So we're making these different colors. Different sets, because this adds up to 10, this adds up to 10, these adds up to 10, this adds up to 10. This must be that digit specifically. So these are all the same. I guess we could make this just essentially... I think it's better to do this way, though, so that you know the sets of 10, right? We know red and blue cannot be here. We also, I think, so green cannot both be here. So one of these is green here. Blue and red can't be here. One of red and blue, at least each, has to be here. But the other, one of the reds, either the red or the blue, is guaranteed to be in this 20 cage, right? This is the greens adding up to 10. So this can't be red or blue. If we had red or blue here, the problem is that, say we had a red here. That means guarantees 2 blues are in here, which add up to 10. And we have a red, but the only way that red could add with... So since we have the 2 blues here, 20 minus 10 is guaranteed 10, and we already have a red here. Well, to add up to 10 with the other digit, it must be the other red. So we're guaranteed this is a blue-red pair guaranteed. So this is green. This cannot be 5, so it has to be pink. This cannot be pink, because if it were pink, that there would have to be an X in between them. So this has to be 5, and this then must be a green-pink pair. So we have the same thing here in row 4, right? Blue, green, and pink cannot be any of these digits. It obviously can't be here. So you're guaranteed one green and one pink at least in the 20. And the other one could be here, but the problem is that guarantees at least one pair of green and pink must be in this 20 cage. And to add up to the other 10, so it adds up to 10, right? One pair of pink or green adds up to 10. So then you're guaranteed the other green here, which means this must be a green-pink pair. This cannot be blue, so this must be red. That guarantees this is 5, so this must be a blue-red pair. But blue and red cannot be consecutive. Or sorry, two reds adding up to 10 cannot be consecutive, right? 1, 9, 2, 8, 3, 7, and 4, 6, none of which are consecutive. So this cannot be red. This is blue, which means this can't be blue, so that's red. This becomes a green-pink pair here. So we have the same here in box 2 and box 8. So then this has to be a combination of green and red. So this is green and red. Pink cannot be either of these, so one of pinks has to be here. This can't be 5, so it must be blue, which means this cannot be blue because of the X problem here. So this is 5. That's 5. Then this is not blue. This has to be green, right? So this is blue and pink here. This is green. This is a pink-blue pair. This is a green-red pair here. Okay, what else does that tell us? I don't really know. There are no V's. That's interesting. Okay, remaining digits in column 7. You have to have red and green. So that's red and green. So these have to be different colors. Oh, that's right. Okay. So red cannot add up with blue or green to add up to 5. The low red cannot be with low blue and low green to add up to 5. So low red must add up to 5 with pink specifically. Right? Blue cannot add up with red. So blue and green must add up to 5 for the low digit. Okay. Interesting. So red and pink. What does that mean? These digits are consecutive. So red and blue are consecutive. Does that tell us anything? Well, these must both be either low or high digits here. That doesn't really tell us too much. This is consecutive. It could be a 5. We're not certain. Remaining digits in column, sorry, row 3 are blue and red. Remaining digits in column 3 are blue and pink. And remaining digits in row 7 are green and pink. Okay. These are obviously opposite sets. This is an opposite set, so we're guaranteed the green already in column 2. Because otherwise these would add up to 10 if this was both pink. This is 1 green and 1 pink guaranteed. 1 green, 1 pink guaranteed. This is blue, so this cannot be a blue here. It's red, which means this can't be. So this cannot be both reds because there would be an X next to it. So this is blue, which means this can't be blue. So this is red. Red cannot be next to it because then that would force that to be add up to 10. So this can't be blue to add up to 10. This can't be blue. This is red and red. This can't be red. That's blue. So we have red, red, blue, blue. This cannot be a green-green pair, so this must be green here. So this is green, which means this can't be green. That's red, which means this can't be red, so that's green, which means this can't be green, so it's red. Because the reason is that we know the reds add up to 10. There would have to be an X in between them, and they can't be there. Green could be consecutive with blue. So 1 green and 1 red here. 1 green, 1 red here. Okay. There's 1 pink here, so that means pink cannot be here. We're guaranteed a pink in one of these two. We just don't know where. Green cannot be either of these two, so green has, okay, there's 2 green here. So green cannot be either of these two because, again, to add up to 10, you can't have be consecutive digits. And these would have to have an X in between them if they're both green. And these double greens eliminates green here. So this has to be green here. Since this is green, the rest of column 9 has to contain only 1 green. If this is 1 green, these would both be pink, and there would have to be an X in between them, which is not possible. So these cannot be both green. So this is the green here, which eliminates green in the cells that share an edge with it. This can't be green. This can't be pink. Red cannot be here. It has to be one of these two. So where's the red in row 2? It cannot be here because that would have to have an X there, so this must be red here. Blue cannot be here because of the 2 blues in the column. So this can't be red, it can't be blue, can't be green or pink, so this has to be a 5. So this is 5, which means green is a 4-6 pair to be consecutive with it, with 5. We're guaranteed a red and a blue here. This can't be blue because of the 2 blues in the column, so this must be red, and this must be blue. That leaves one of these as 5. So we have a 5 and a pink here. We're not sure which is which. This has to be blue because there's no other. This is a blue-pink pair because there's no X in between. Remaining digits in column 8 are green, and pink. Okay. Remaining digits in column 9 are 5 and red. Actually, let's make the pink not pink. Let's make the pink orange. And we'll make the 5 possibilities as pink. So these are all 5. Let's see. Okay. So this is also pink as a possibility. Blue and red are consecutive. So green and blue add up to 5 because blue, the low digit is guaranteed to share a low digit with red and guaranteed to share a low digit with orange. So therefore, blue must be 1 and 9. So this has to be 1, 9. Whoops. Which means red is 2 and 8. Because we know the red is consecutive with the 1, 9. So red is 2, 8. Orange then has to be 3, 7. Okay, let's remove the ones that are not guaranteed right now. Oops. So all the reds are 2, 8. All the greens are 4, 6. All the yellow oranges are 3, 7. Okay, so let's get that again. This is pink or red. This has to be green or orange. This has to be green or red. This has to be green and red. This has to be some blue-orange combo. This is blue-orange. This is green-orange, and this is green-orange. This is blue-orange. These cannot both be blue. If they were both blue, that would force this to be orange, so this can't be orange. This is blue. Which means this can't be blue, so that's orange, which means these can't be orange, so that's blue, which means this can't be blue, so that's orange. Let's see. This is green and orange, that's fine. That's done. This is a blue-orange pair. One of these is pink, the other one is orange. This cannot be green, it cannot be red. So we have, where's blue? Blue cannot be here, so this is guaranteed to be blue here. This can't be green, so it's orange or it's pink. So this could be 5. Any of these could be 5 here. We have pink as possibilities here, and then we have green or orange. Okay. We are guaranteed a red here because it cannot be both green. Therefore, this can't be red. Therefore, it's 5 in pink, which means this can't be pink. That means this can't be pink either. So pink's one of those two. Um, hmm. Hmm. Okay, so these are 1, 9. These are 3, 7. Hmm. This is red. Hmm. Okay, so these are all the same digit. Let's make this A, and this is Z. Then we'll have B here and Y. I guess we'll keep going around this way. C and X, and then this is D and E, W. Okay. We don't have any other really restrictions here, though. Hmm. This is B, so this must be Y, so that makes this B, which makes this... Actually, we do kind of have restrictions thinking about it. Okay, so let's... So this is A. We have Z here. B and Y. C and X. D and W. So this B forces this to be Y, which makes that B, which makes this Y, which makes that B, makes that Y. This is B. That's Y. This is B. This Y means this can't be Y, so it's B and Y. That makes this Y here. Where is Y then in row 8? It has to be here. So this is not green, it's red, which means this can't be red, so it's green, which means this can't be green, so it's red, which means this can't be red. So this is B, not B, this is Y. This is B. We should have all the B's and all the Y's then. A and Z, which makes this A. A makes this Z, which makes this A, which makes that Z, which makes that A, which makes this Z. Z eliminates Z here, so this is A, which makes this Z. You can't have green here because that would be 2 greens in a row. So this is not green, that's orange, which means this can't be orange, that's green, and it's A. We can no longer have 2 greens in row 9. We have 2 oranges already here, so this can't be orange. It's green, which eliminates green here, so that's orange. This can't be orange anymore, so it's green. This can't be green anymore, so it's orange. This can't be orange, so it's green. This is Z. This is A. This is Z. Okay, so we're done with all the greens. What about blues? C and X. That makes this C, which makes that X, which makes this X. And this C, X, C, X, C, X. That makes that X there. C is one of these two. C is one of those two also. Okay, D and W. D, W, D, D, W, D, W, W, D, D. So D cannot be the digit that's here. D cannot be here, so we need a W here. W cannot be here. Where is W in row 2? It has to be here. So this is W, which means this is not blue, so it's orange. These can't be orange, so this can't be blue, which makes that orange. So this can't be orange here. It's pink, which means this can't be pink. So this is orange, which means this can't be orange. It's pink. That can't be pink. So this is W here. We have 5 here. W here. 5D. This is C, and that's X. Okay. So, again, we know blue and green have to be adding up. The low digits have to add up to 5. X is next to Z. What about A? Is it next to A at all? I don't see it. What about C? C is next to Z. So Z cannot be the low. A is definitely the low. So that means A is the 4. Okay. So A is 4. Because Z is both next to C and X. So Z has to be 6. 4 cannot be next to C as a 1. So C must be 9 and X must be 1. Okay. 1 is consecutive with 2. So Y has to be 2 and B has to be, not 3, 8. 2 is not consecutive with 2 and W cannot add up to 5, so W has to be 7 and D has to be 3. Wait, did we mess something up? We have we have too many 1s. Okay. This can't be 1, that's 9. And that's a solution. Yeah, fairly... I don't know. I guess if you know how XVs work without if given the negative constraints of X's and V's, this is fairly straightforward, I guess. But you do have to know that. That's why this is I would consider this challenging, right? You can also pretty much deduce most of this stuff. So yeah, seems decent. Just don't make a mistake like I did there. But I mean, it is rather easy to make potential mistakes, but yeah, what can you do? How did I... Oh, I had double X there. That's the reason why. Okay. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.